Hello, 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 hello. Yeah, so we are live again, and this time hopefully the quality of the video is good. Let me check that first. Yeah, so we are live again, and this time hopefully the quality of the video is good. Let me check that first. Perfect, it is good. Now I think we can move ahead with streaming. Yeah, so where were we? Yeah, we now have to check. So I think I gave a brief intro of things that were happening in the mist offline stream. I think I don't need to upload the stream again, but we have to check that whether what is the how do you how is this frame buffer object being used? As in, is there a way? So maybe a starting point could be I do some sort of manipulation on a frame buffer object, and then I then use that frame of a buffer object to show the screen or something like this, right? Let me first check. Is there an example? First, the bind texture, right? GL bind texture. That is GL bind texture. Whether that is present. Just let us check that. I think this has no document. I mean, not textual documentation. Yeah, that is not. There's nothing here. GL band texture. I think in that Chronos one, it might be there. Documentation. GL band text. Target. Yeah. Specifies target to which texture is bound. Must be of type one of 1D, 2D, 3D, 1D array, 2D array, rectangle, cube map array, texture buffer. Okay. Okay. Texture buffer seems interesting. Let us search with GL texture. Yeah, so might be the command attach texture to the created frame buffer object. Yeah, this is possible that this is correct. And uh, now we need an example in which this is actually done, right? Android OpenGL frame buffer object example. And this is some. Okay, this Stack Overflow question I need to understand. I have a NV21 camera video which I'm applying on it a fragment shadow in order to get some filter effects and YUV to RGB conversions. Everything is working except the bad performance. My fragment shader is a bit heavy because it has many texture 2D calls. The original frame resolution is, I noticed that if I am setting the viewport to this original size, it is working good and fluently. So basically, I need to first render the frame and processing it in a frame buffer with that original size, and then scale it to full screen size using viewport. And it means that the heavy processing work would be applied on much less fragments. Okay, I found out some tutorials and similar questions here how to achieve that, but unfortunately I have got no luck with that. This was 6 years ago, by the way, and I think still the same things. I'm not finding any tutorial with respect to that. So basically an idea that I'm getting is, if the processing cannot be done on a very large area, right? Suppose the view itself is pretty big, right? Suppose the number of pixels there is pretty big. It can be downscaled into some sort of a size in which we can do the processing, and then we can directly use the image. That could be one of the ways of solving it. Uh, that is an idea that I'm just putting out. Maybe I'll just capture it in the in case of the computations taking a lot of time for screen fragment shader, we can do the computation for lesser amount of fragments pixels in a frame buffer object, then scale the frame buffer object to fit the screen. The solution might not be desirable, but it will at least run, right? So that is one of the ways in which we can solve the problem as well. This is something that is good to know, because earlier what I thought was one of the approaches that I was trying earlier was I was trying to solve this on a 30 into 30 array, then just fit it on the main screen, right? But it looks extremely choppy. As in, the 30 into 30 looks extremely choppy because of obvious reasons. Because but now in with this, maybe we can try and get a better output with this. Although there is a lot of things that still needs figuring out, but at least a small thing that we might use at some later point of time. Yeah, I've still not completed reading my code and reading the question. Now I have to read the answer. I found out some tutorials and similar questions here how to achieve that, but unfortunately, I have got no luck with that. Any help would be appreciated. Also, another performance tweaks that I don't know how to deal with is to combine somehow these three textures to a single texture which be uniform to the shader. Here is my renderer code. Okay, let's just take the. Okay, some guy has given some solution now. First, we'll read the English solution, then we'll go through the code. Code we can copy paste it somewhere. I am not very comfortable reading the code from here. Or is it only this much? No, it is a lot. Just a class, right? Yeah, it is just a class, my renderer. I think we can just create a class in our Android Studio, and then we'll just comment it out basically and check what is happening to easily understand what is happening. What are you trying to do is called downsampling. What you need to do is to render first into a small FBO where both the viewport and the FBO attachment are the same size. In that pass, you can apply your blur effect. Then you can render or blit it to another FBO of the original size to get the texture scaled back. It's important to note that depending on your blur technique, the upscale result may have noticeable degraded quality, which is all known because if you do it on a smaller samples, the quality is compromised, but it is a compromise that we are willing to take based on. I'm not just saying about this particular case. I'm saying about the our case as well. Speed versus performance, right? Speed versus output quality, basically. As some OpenGL API calls may have different namings in Android SDK, here is the general pseudocode for what you need to do. Let W equal to original width and H equal to original height. Create a custom FBO and texture attachment of size W by H by 2. Attach the texture to the FBO. Bind the FBO for right. Set GL viewport to the same size as the FBO texture attachment. Render a full screen quad. Apply your effect during the pass. Second pass, bind back the attach the texture to the FBO. Bind the FBO for right. Set GL viewport to the same size as the FBO texture attachment. Okay. Render a full screen quad. Apply your effect during the pass. Second pass, bind back the default frame buffer. If you just want to split, then make sure you bind the first FBO for read and not for write. Bind the texture attached to the FBO from the previous pass to the sampler unit. Set the viewport to WNH size. Draw the full screen quad. Do in the fragment shader whatever you need. Gamma corrections, blending, etc. So basically, there is a texture associated with the smaller frame buffer object. Then the output of the texture is given as the input for the larger frame buffer object, and the larger frame buffer object does the scaling and you see an output basically. This is somewhat similar to our problem statement as well. Although I don't think we need multiple frame buffer objects, but we might at some point of time if the computations need to be done in smaller frame buffer. I think I just copy this into this thing. I'll not be using it directly, but I'll just comment through this code. Well, let's see what is happening in this. I don't find any other code anywhere. In case of Android samples. So. My renderer. Does it have a package code? The import is not. Okay. There is no import that load buffer I would do this. Short buffer. Buffer. Entrant. I think anyway this is all irrelevant, but let's try and draw let's try and draw sequence diagram for this. How many methods are there in this? On surface created, setup textures, update textures, on surface changed, on draw frame. Display frame, display video, disable video, enable video fit. There is a companion object, and there is a load shader in the companion object. There is a init. We'll just document it down just to make Sure. Or maybe we'll just draw the. I have a tendency of writing the method names and all just to. It somehow eases me into reading code. Not sure whether this is helpful for others, but anyway, this is it is kind of a way of reiterating to myself that okay, only you have to understand 10 methods. So after one method, I'll be writing okay, now you only have to understand 9 methods. So it gives a percentage completion feeling as well. So that is why you write it, and you kind of get with the names and all right. You kind of get a higher level idea of what is happening in these functions also. Sometimes, depending on the standard of naming, of course. But yeah, but let's anyway add these method names here. Uh, Method names in my renderer. Uh, Stack Overflow. Okay. I think easier one init it on surface created on surface draw. These things we know anyway. And now we'll move on to stuff is very specific to this code. There is a companion object with initialize texture and load shader. Initialize texture and load shader. This is many methods 1, 2, 3, 4. There's 6 methods. Then enable video fit, disable video display frame. Enable video fit, disable video display frame. Update textures, setup textures, update textures and setup textures. Update this. So basically, these are the methods that are present in the code. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 methods are present. I think a couple of them are like one line code and all. But basically, there's a 11 method class. Say like that. Each method you will be somehow completing like 100 by 11. What is it? 9 9.4. 9.09, right? 9.0909, I guess, around 9%. But yeah, that is fine. Give me a minute break, I'll get water. Yeah, I'm back, I guess. So where were we? We went through the code and we understood that there are like 11 methods present. We will see what all the variables are present here just to get an understanding of the class. There are texture IDs, scale matrix, filter scale matrix, vertex buffer, texture buffer, draw line buffer, video buffer, frame buffer again, video fit enabled, video disabled, vertex index, vertex shader code, fragment shader code. Why is fragment shader code just one line? Ah, they are the same, put the code there. Right? Some locks are there. Then program filter, texture width, texture height, viewport width, viewport height. Now we will just see the entry point, right? On surface created. What is happening on surface created? We have to see what is happening on surface changed. I mean on draw frame. What is happening on init? is uh, using main app to under in my view due to my address. It's commuting and my view as the renderer. Now we'll see what is happening in the renderer in the init. My vertex buffer, my texture buffer, and my promised buffer. Initialize vertex buffer, texture buffer, promised buffer, and frame buffer. Nice. Vertex, promised, text, frame. Okay. In my renderer to my system to my renderer. My renderer created. So this is the initialization of vertex buffer, texture buffer, and draw list buffer. We move to the surface created code. This is how many line big? 43 to like 40 for 50 lines big. This is. We disable depth as we clear color. We load shader, vertex shader, fragment shader, and filter vertex shader, filter fragment. Okay, there are 4 shaders that get loaded. Now m program is equal to create program. Then we add the vertex and fragment shader. We link the program. Then program filter is create program, and we attached So basically, one program is for the OpenGL's ES thing, and one program is for our local frame buffer object, right? So here also you attach a shader and then link the program. Now your position handle you have. Basically, these are the same things that we understood yesterday as well. But instead of directly providing into the OpenGL pipeline um, for the direct rendering, we might in some cases uh, do it for an offline frame buffer object as well. Is what my understanding as per now. Yeah, where were we? We have a position handle. We have a texture handle. Uh, and we are passing these handles to which program? To the vertex buffer, texture buffer, texture handle. We use program. We are passing all this to the GLES pipeline, M program, right? The other is M program filter. Okay, now after which we do okay. We pass vertex, utex, vertex, uh, and we pass it to M program filter. We pass variables for M program, and we pass variable for M program filter as well. So basically what we are doing here is non-surface created. We create shaders for OpenGL as well as shaders for uh, let's just create two programs corresponding shaders variables. Create two programs corresponding shaders variables. Yeah, this makes sense. Now my renderer, my renderer, draw, right? Draw. On draw from is again 60 lines big. This what is happening in on draw frame? We do color buffer bit clear or something like this. Then frame lock dot lock. We do this current frame by the way. The frame. What is this frame class? Current frame, right? What is the frame class? I have no idea what. Like in the variable, second variable frame, I'm not able to understand where it is. Maybe it is a user created object, the frame. It's quite possible. But yeah, we'll look into that. What is this frame and what is the on draw object, right? On draw frame. But it take like couple of minutes. Let me take a couple of minutes break and then I'll be up and back basically. Back after that. Let me take a couple of minutes break. I'll be back after that. It's became 5 minutes, I guess. But let us check um, the live stream first. This works, I guess, as in the streaming is happening. Sound noise gate, I have to actually make sure that it actually is in a better place. That the noise gate works better. But other than that, we are good to go. And we were stuck on what is frame, right? I think let us move past that. Where all are we using this current frame, and what all we using of this current frame? It has a width, it has a height. Then setup textures, update textures. Width height is mirrored something. Recycle, unlock, recycle. Setup textures, what is it doing in this frame? Byte buffer is there. Setup textures, get width, get height. Okay, we'll see what is happening in setup textures, right? In setup textures, we are actually deleting, reinitializing and generating textures. And then we get a width and height, which is the frame buffer's width and height, I would assume. And then it's half width and half height. Then initialize texture. What is initialize texture? No idea what is this. Okay. Basically setting the parameters for the filter and all. And what does M textures have? M texture IDs. I have no idea what to do with this M texture IDs. Uh, lot of things happening in case of this setup texture and generate texture, man. Lot of stuff is happening in that. Uh, not so the streaming in itself is a difficult process, right? Otherwise, you would think to yourself and talk to yourself and then figure things out, right? Now, while streaming, you're trying to do this. I mean, sometimes talking a lot is kind of draining, but yeah, but that shouldn't block me. And also, this buffer thing is actually buffer thing is kind of painstaking currently to understand the concept. This is like, as I said before, getting to know any other concept. Initially, you would be kind of facing some issues with respect to this, but at some later point of time, you usually make sure that these things work correctly. But yeah, I think I don't know why I'm feeling tired currently. I didn't get sleep also. Maybe I think it's an hour stream done. It's a hour of streaming done. I think maybe I'll stream a bit later. I'm feeling a bit tired, I guess. So maybe I'll come back after some point of time and then complete the frame buffer thing. But or maybe after half an hour also. That is also possible. But yeah, wrapping your head around a new idea, right? It's always kind of challenging, and you want to give some space to yourself to seep in and all that, right? Maybe that is the reason, or maybe I'm just tired because of sleepiness and all. So let's see. Anyway, yeah, I'll be back after maybe half an hour, and or maybe in the night. I'll stream the rest of